Our unit on plate tectonics starts with Alfred Wegener. Alfred Wegener was a lot of things: an Arctic explorer, a geologist, a meteorologist, paleoclimatologist, and he had a big idea. When he looked at the map of the world, he noticed something. Take a second to think about what that might have been. But what he noticed was that the continents of Africa and South America looked like they once fit together. And the more he thought about it and the more evidence he collected, the more he became convinced that at one point the world's continents were used to be together, and then they broke apart and drifted away over time. And we call that idea continental drift. So I'm going to put the definition for continental drift up there, and I'd like you to write it down. It's the idea that the world's land masses are slowly moving over time. And if the continents were drifting away from each other over time, there must have been a period in the past when they were all together. And Alfred Wegener believed this, and he came up with a name for it. He called this supercontinent, the continent that made up all of the world's land masses, Pangaea. So I'd also like you to write this down: the supercontinent made up of all continents that existed millions of years ago. If you break down the word Pangaea, it means whole earth. So in Alfred's mind, it looks something like this. On your notes, you have 3 circles under the heading, the breakup of Pangaea. And so what I'd like you to do is first draw Pangaea in the first circle. It doesn't need to be perfect. It can just be a blob of land masses. But I'd like you to write Pangaea and then include the year underneath or above, 225 MYA, which means millions of years ago. Over time, began to drift into the Triassic Age, the Jurassic Age, and this is the one I'd like you to draw in the second circle. Over time, things continue to drift apart. We got the Cretaceous period all the way to present day. And this diagram I'd like you to draw in the final box, third circle. Now, if you think about it, it really was a pretty bold claim that Alfred was making. The continents are big and continents are heavy. Think about the earth under your feet as you walk around or go over mountains. Alfred Wegener was saying that these things actually were able to move and drift and float. And you really need some big evidence to be able to back that kind of claim up. Alfred Wegener was pretty determined to do that. So he went out and found 4 key pieces of evidence. Call them Alfred's evidences. The first piece of evidence is geometric evidence. And geometric evidence is based on the idea come together right now over me. So in your boxes of evidence, you'll write this one under number 1, geometric evidence, and you'll need to include the description. And the description is that the continents appear to fit together like pieces of a puzzle. And yes, you're going to have to draw this. Do the best you can. I'm sure it'll look beautiful. The second piece of evidence was fossil evidence. Obviously, Alfred had to go beyond just geometric evidence. And, it's cool to think about and it looks neat, but it could still just be a coincidence. So we started looking and researching, and one of the first big things that he found had to do with fossils. If you were to look at the fossil distribution, and that's where they find particular different types of fossils, he noticed an interesting pattern. So we've got the distribution of and I'm not going to pronounce this right, so I'm not even going to try, like so. And then you've got a different fossil over here. And if you looked at the distribution of the Glossopetrus, that's this one. And then finally, could also look at the distribution of the Mesosaurus, who was one of the larger freshwater animals, fossils that we've been able to find. He noticed something interesting. That's going to bring us to box number 2. And this is what you'll write in your notes. The fossil evidence is that the fossils of some species are only found on matching coastlines of continents that are now separated by oceans. So you'll write this down and include an illustration. The third piece of evidence, which is somewhat similar to fossil evidence, but a little different. So Alfred also looked into the world's mountain ranges and the evidence that they were able to provide. So think about what mountain range might be here in this general area. If you thought Appalachians or Appalachians, depending on if you're from the north or the south, you would be right. And he had a hunch that this mountain range that ended on North America was the same one that picked up over here on Greenland and here in Africa and also up here in Europe. He thought that it all used to be part of the same mountain range, and that mountain range was ripped apart as the continents drifted. And these weren't the only mountain ranges that he observed. There's actually others, particularly found on the border between South America and Africa. So the idea goes something like this. Over time, continents drift apart and oceans came in and filled the gaps. You can see that here. And when you look up closely at these mountain ranges, you would see that the actual rock patterns within these mountain ranges actually match up. So the third piece of evidence for mountain evidence is that mountain ranges end on one coastline and pick back up on another. If you are having some trouble on how you want to illustrate that, I would probably do something like this, showing before mountain range together, and the mountain range is separated by ocean after, including the matching rock patterns. Now, Alfred's specialty, his scientific specialty, really was climate. And the last piece of evidence actually is climate evidence. Now, obviously, this is a bit of an exaggeration. They're not tropical plants on Antarctica, but there is strong evidence in the form of things like coal deposits that tropical plants used to grow in Antarctica a long time ago, when its position on Earth was different and in a warmer area. So the fourth piece of evidence, and just quickly because there's 3 dots at the end of this beginning sentence, know that that means it continues, so don't write it too giant. But climate evidence says tropical deposits of coal prove that tropical plants used to grow in cold areas like Antarctica. And evidence of past glaciers are found in places that are too hot today. Here, if we were to look at Pangaea and sort of the breakup of Pangaea, you can see that the glaciers, which would have once been very close to the southern tip of hemisphere, now be found in some areas that are warmer today, particularly the tips of Africa and South America. So again, let's remind ourselves what the 4 pieces of evidence were. Geometric evidence, the idea that the world's land masses slowly fit together at one point. Fossil evidence, that you can have a distribution of fossils that end on one coastline and pick back up on another. Mountain evidence, that you can have mountain ranges that end on one coastline and pick back up on another. And finally, climate evidence, which says that the climate, there's evidence of warm places or warm things like tropical plants in places that are too cold today for tropical plants to live, and evidence of things like glaciers in places that are too warm today for glaciers to be. Despite all of this evidence, which I think is pretty darn convincing, Alfred Wegener was still largely disputed at his time. It turns out that despite all of his great evidence, Alfred Wegener was still rejected by a majority of his scientists during that time. What do you think that the problem was? Why do you think that Alfred Wegener was rejected? What's missing? Turns out that despite all of his evidence, Wegener could not explain how it happened. In other words, he did not have a mechanism. Sure, it looks like they're moving, but how are they moving? How is it possible that these massive chunks of Earth could float around? Alfred couldn't explain that. So I'd like you to write that down. This is actually the end of part 1. So we will continue.